How's Charlie?
Now you had two.
Two
parallels.
What's that?
Yeah,
She could not.
I put that on for you. Or give you songs. Okay, so last we were here, we were working with simplifying things with exponentials, and not necessarily solving anything, but like that's the whole idea, is that you can take something with exponentials in it that are kind of ugly, you make it pretty by simplifying, like you've done before, and this is just the kind of logical next step, which is solve an equation involving that. I'll show you a couple of tricks, and then I'll show you how to blast anything that comes your way, provided you have a calculator, and it'll be fine. It'll be fine. So an exponential equation, surprise, surprise, has an exponential in it, like that, 2 to the x, right? It's not x squared. Just because you see an exponent, that thing, this is not an exponential equation. It's a quadratic, right? The exponent needs to be the variable to make it exponential. This is just a quadratic because we know the exponent. And this we can solve with quadratics. This one we have to solve in a different way. One of the ways is logarithms. We'll get there eventually. We're not gonna mess with that today. So if you know like 2 to the x is 8, I know that I've got a bunch of 2's, and I don't know how many. I gotta get 8, and you can count them 2, 4, 8. Hey, 3. You can use logs. You can do a couple other things. So if you have something like this, 2 to the equals 8. Well, I know that 2 to the x equals 8. The x has to be 3. So you could do the same thing if you wanted to do this formally. And sometimes this helps. This format helps as the math gets uglier. What you could do is say, let m plus 1 equal x equal k. Making stuff up, and then rewrite it. This is too much work for this one, but I wanted you to see it when it's easier. So you'd say, oh, instead of this, let's call it k, just to make this a little bit easier. 2 to the k equals 8. Well, 2, 4, 8. K should equal 3. Hey, but k is not k. K is m plus 1. So you switch that out. M plus 1 equals 3. What does m have to be? Subtract 2. Right? That's you don't have to write this piece out. But when I don't, I mess it up and forget it, and I leave it like this. K equals 3, and I get super proud, and I walk away and go have lunch and coffee, and I forget to resubstitute. So writing that down helps. Right? Do you need to do it every time? Up to you. It's your artwork. Cool? There's always somebody in the back that's like, or you could use logarithms. It's true. It's true. You could use logarithms. And if you're confident with logs, blast it with logs. It's great. Everybody loves logs, right? So totally, all of these you can use logarithms to solve. We're going to do a whole unit on logarithms, so we'll get there. All right, trick number 2. We did that one. It's 4. Try that one. Try this one.
E.
No, it's different. Try B. I keep these knobs. Hi, I saw you coming. Look at that thing with your nerd goggles on and find the 3, the base 3 in there.
X plus 2 equals
Well.
No, it's x equals negative.
Why?
Just subtract. No.
Now it's vertical fraction.
No,
It'll start slowing you down. The slash fraction, it's going to start slowing you down. Try to make it vertical. I see like base 3s there, and it's kind of our goal to just like make it all base 3. If we could do this trick, if we knew this equals, I'm making stuff up, 3 to the smiley face. If you didn't know we'd made it up, you could equate the x plus 2 and the smiley face because they're both base 3. So that's the trick that I want to do. So I've got to look at this with your nerd goggles on and see the base 3 in there. This looks like 1 over 3, 9, 27, right? So this is 3 to the third. That's a 3. And that really is 3 to the negative third. If you're not sure, punch it in your calculator. You get the same nasty decimal. Therefore, since base 3 to that power and base 3 to that power are the same, you could essentially what you're doing is take the logarithm of both sides, but we can just equate the exponents. So you say therefore 3 dots means therefore. It's instead of putting another equal sign because you already have an equal sign here, that looks atrocious. That's like just blatantly wrong. So you say therefore, and that looks fly, right? So then you can say therefore equals negative 3, voila. Subtract 2, right?
You have to have the 3 dots.
You don't have to have the 3 dots. It looks cool. You can just leave it like that. Do not do that.
Do that.
Equals, 2 equals in a line? No way. I will make fun of you. You can leave it like that, but boop, boop, boop. You see that in my work? That's just kind of like how we do it. As we take like a big step, sometimes you say, therefore, this is the case. Yeah.
What about it's like basically an equal sign, but then it has like an arrow thing.
Like that?
No, it's
Like an arrow
smiley
but with
thing.
2 lines.
Yeah.
Oh, sure. Yeah, sometimes you see that. I don't like that as much because it looks like an equal sign, and this is an affront to mathematics. So this, for me, isn't too far away from that, and I think this is a little cooler. And usually, like, as you're, like, writing about, like, what you're doing, this is a pretty easy step. This is a bigger step. So you go, okay, therefore, and then you just keep saying equals, equals, equals. And whenever you see like kind of a bigger step going over, this kind of signals your reader that like they should kind of think that you're pulling a little bit of a trick, and they need to think about what's happening there. Cool, not too bad. Neat. Neat dog. And for my last trick. And for my last trick, that thing. What do you have? What's your spider sense tell you that is?
Use dogs.
It's, well, what kind of equation is buried in there? Yeah, there's a quadratic in there. And so you've already messed with simplifying this. And so you could do this by, you could say 4 to the x is really 2 squared to the x, and 2 to the x minus 20. Rearrange those and see what you get from there.
Would it be 2 to the 1 to the x? For the other function? We're trying to make a basis of 2.
Yeah, good, I like that. So this is, maybe switch the 2 place of being exponent 2 and exponent x. So it's x 2 to the x squared.
Or divided by 2.
Is it when it
2 to the x to the 1.
you know the 2 brackets?
Yes.
So I don't know what
Very
it's
similar.
doing.
Binomial. 2 binomials.
Oh, I meant like the answer.
Oh, could be. It could be. All right. So just to refresh how you turn it, you can just switch those places. So eventually, I wanted to call this 2 to the x squared. Well, let's just do that. 2 to the x. Avert your eyes. Give away the punchline. There. Minus 20. And equals 0. What you're doing here, this, Johnny. What you're doing with that, you're calling this 2 to the 2 times x. You multiply those. And then you're just switching places. 2 to the x times 2, because 3 times 2 and 2 times 3 are the same. And then therefore you can call this 2 to the x bracket squared. I like that because this looks a little more approachable. And you don't need to, switch out and maybe say, okay, so well, let's let m equal 2 to the x. You can say, okay, well, therefore, m, this is m, so m squared plus another m minus 20 equals 0. Sometimes that's a little easier to see how the factoring is going to go. Do you need to do it? Nah. But like this is pretty straightforward, 4 and 5, right? But once there's a constant out front, a coefficient there, and once the factoring's a little uglier, sometimes this simplifies it, so I can see the factoring a little bit better. So let's try that out. Oh yeah, that's perfect. That's exactly what I want to do. So then this turns into minus 4 and m plus 5. equals 0. D. And therefore, I equals 0. And so we can resubstitute in. M was really 2 to the x and 2 to the x. What's the little fussy bit here?
You have to work out what like the thing is. Equals 0.
Indeed. Yes, great. So if this chunk and that chunk are multiplied and you get 0, either this first part equals 0 or the second part equals 0. So 2 possible solutions. You add 4 to both sides, you get 2 to the x equals 4. Gotta be 2. What about that one? Well, yeah, good. Even if it's, let's pretend this was 5, right? If this was 5, yeah, you'd use a calculator and a log. It's 4, so we can kind of do it in our head. This one has a more egregious problem than not being easily to do mentally.
Negative.
Yeah. So when you take this, when you subtract the 5, this is like, I've got a bunch of positive 2s. Positive 2, and the positive 2, and the positive 2. Get out of here, Urkel. I don't know how many of them, but I need to get to negative 5. Doesn't happen, right? And you can see this in the log graph, too. If you graph this, I know you love graphing. 2 to the x looks like this. Woo! When does it go negative? When is it down here at negative 5? Never, right? And so this is sort of a rogue, a phantom solution, right? So you'd say, no solution there, right? And so this is your only solution, even though quadratically it suggests that there might be 2 solutions. Sometimes there are, but you got to use like your prowess. Neat. Last trick. Let's do this. Well, let's do this one. Let's do this one with our calculator. I just want to show you how to run this with your calculator regardless of what you have. So I want to find, we already did that by hand. I'm going to pretend that you whacked your head coming in here, you slipped on the ice, and like you don't remember how to do anything except run your calculator. Here's your calculator. So I'm going to put this in for one y equals, and this in for the other y equals. So I'm going to call it 3 to the, make sure you got some brackets in there, x plus 2, close your brackets, then 1 over 27. You might have to be careful with your brackets, but cool. So it should look like that. There. And then I'm going to say zoom 6, or zoom standard. Right? Gross. They're pretty close. So now we got to go hunt for the spot that's like right in here. Right? 1 over 27 is pretty small, so it's like pretty close to 0. So let's bring our window from x. Let's make this even farther back. I'm going to go negative 20 up to, I don't know, like 0. And the y, I'm going to go from 0 to 1 because 1/27 is like partway between there. So I'm just trying to zoom in on where I expect the intersection to be. And this is like fussy, but it's definitely part of the dance, right? So if you go from, just make sure your signs are correct. So my negative is negative 20, 0, scale 1, my minimum, my maximum. Okay, so let's try that. There's that. There, right? So I kind of zoomed in, right? Like just where I thought that where I thought that this intersection might be. I guessed on the negative 20. I just said I want to see really far back that way. I don't need to see past 0. And I know that this is going to be pretty small, but not past 1, not past 0. So got that. Fuss with your window until you got that. Like that's the whole problem, is messing with the window. This is, can you drive your calculator's window problem. And then you'd say second calc, go to intersect, d. Enter, enter, enter.
How am I supposed to
And there we go.
That's tiny.
That's tiny.
But when you do traces, that's pretty
Well, but all we're looking for is the x. So we're looking for -5. And that's what we got last time, right? When we did it by hand.
Yeah.
We got x is -5 in here.
The window, but we have to
Huh?
trace it.
That's pretty good.
My window is fine.
Seconds calculate.
Yeah.
Cool.
Interesting.
Yeah.
So I know that that's fussy, but if you can kind of drive your window and be a little bit intuitive, you can solve anything with a calculator always, which is pretty sweet.
I don't
I was gonna guess it.
As a solver,
I got it wrong.
you can use a table, the table as well, but then you have to go hunt for it in the table
Yeah.
as well. I don't think there's an exponential equation solver.
Okay.
There is like a quadratic solver, and there is a systems of equations with like 2 lines
Yeah.
that'll solve for you. But that's why we learned to do this, because after like quadratics, it starts to break down about like how it solves problems, and then it switches to a different style of solving using some calculus.
Okay.
And it'll be able to solve anything using that, and only some things using this other method.
Okay, cool. Thank you.
Cool. Yeah. Good. Questions, comments, concerns? Sweet. My solutions are up and rolling. We're going to do some exponential equations. So we should be done with that page by the time you're. By the time you're ready? Or by the time you see. Cool.
What do we do?
Exponentiale Equationen.
Sometimes the solution that you lost wasn't a real solution, but sometimes it is. Just like if you say x squared equals.
That's pretty good.
Should we format somebody? No, like seriously, before.
Sure.
If you
Yeah.
cancel these out,
I think that's a great idea.
then you're just left with this.
The other thing, no background music.
This is a solution for this. This would be a solution. But because this
Yeah,
is you could also make this true by
Better
putting 0.
Let's see ourselves back.
That's true. So you lose the solution by canceling this out. And so we let the factor and make the cases because it keeps I think in this case it's better.
Are you an example that would be further?
Let's see where I'm negative.
I've probably not one.
Swing for the fences, son.